Okay, here's example G. We have the log of the square root of x squared minus 3x equals a half. Now this one it looks like it's messy, but it's actually not that bad a solution. And so to solve this equation, what I'm going to do first is, and again, there's a couple of different ways for you to solve this equation. First of all, if you recognize that there's only one term on the left and one term on the right, you can automatically write this as an exponential equation with a base of 10. So you can recognize that the base here is 10, and then write 10 to the exponent and a half equals the square root of x squared minus 3x. That's one way of solving it. Another way of solving this is to apply the power law of logarithms. So we actually have two examples where you have a square root. So in this example, I'll show you one technique, and then in the next example, I'll show you the other technique. So this technique I'm going to use is to apply the power law of logarithms. So what I'll do first is rewrite the square root part as an exponent of a half. Okay, so I just rewrote the way I had the logarithmic expression. And then from here I can apply the power law of logarithms and bring 1/2 down as the coefficient of the logarithm to get 1/2 log of x squared minus 3x equals 1/2. And you'll notice that both sides of the equation have a factor of a half, so I can divide a half on both sides. And what that'll give me on the left-hand side is just log of x squared minus 3x. And on the right-hand side, a half divided by a half is just equal to 1. So now I don't have any more exponents on the logarithmic part. And so now what I can do is rewrite this as a quadratic equation. And so what I'll do is rewrite the equation as an exponential equation, and then I'll recognize that it ends up being quadratic. So 10 to the exponent 1 should equal x squared minus 3x. And if I rearrange this, I get 0 equals x squared minus 3x minus 10. And I'll notice that on the right-hand side, the equation that I have is factorable. So I get x minus 5 and x plus 2. Okay, so adds to negative 3 and multiplies to negative 10. And then that means that x is equal to 5 or x is equal to negative 2. Now, in order to check to make sure this is correct, I do need to plug it into the equation because I need to make sure that the logarithmic part has a positive value, not a negative value. So let's plug it in, and we get 5 squared for the first one. We check x equals 5. We have 5 squared, which is 25, minus 3 times 5, so that's 15. So 25 minus 15 gives me 10, which means this will give me a positive result because I'll just get the square root of 10, which I know will be a positive result. Okay, so just to show you what I mean, all I did is I plugged it into the square root part, or the expression part, and I have 5 squared minus 3 times 5, and that gives me a square root of 10, which is a valid solution. Okay, same thing with the next one. We'll plug it into the equation to make sure it's valid, and I'll show you the calculations for that. So I'm going to check to make sure that x squared minus 3x gives me a positive result. And so I get the square root of negative 2 squared minus 3 times negative 2. And so that gives me 4 plus 6. So that gives me the square root of 10. So again, this one is also valid. So in this case, we actually have two solutions, and both the solutions are valid. So it is possible for you to have more than one solution. It just depends on the case that you're looking at. So in this case, we had more than one solution, which is good. Okay, let's take a look at the next one. Okay, so this example, again, we have a square root. And so I'll show you a different way of solving this one. And so the last example we looked at, I used the power law of logarithms to get rid of the square root and rewrite it as an exponent and a half. And so in this case, I'm not going to do that. I'm just going to go straight into writing an exponential equation. So I know that the base of the logarithm is 10. I have a single term on the left-hand side, a single term on the right-hand side. And so I can rewrite this as 10 to the exponent 1 equals the square root of x squared plus 48. And so at this point, what I could do is to eliminate the square root here, we know that we can just square both sides of the equation. And so what we'll end up with on the left-hand side is 10 squared, which is 100, equals, the square root and the square will cancel each other out to give me x squared plus 48, which is much better than the way it looked previously. And so our last step is to solve for x. So now you'll notice that we only have one x term. And so what I could do is rearrange the equation so that I have the x term on one side and the number of parts on the other side. And so I'll subtract the 48 from both sides to get 52 equals x squared. Now, in order to solve for x, since it's a quadratic equation but with only one quadratic term or with one variable term, what I could do is just find the square root of both sides. And remember that anytime you do find the square root, it's plus or minus. And so what I get is x equals plus or minus the square root of 52. Now, again, I have two solutions. I have x equals the square root of 52, and I have x equals negative square root of 52. Now let's find the exact values here. And so if I find the square root of 52, I get about 7.21. So I have x is approximately equal to 7.21. Sorry, these are our approximate solutions. And x equals negative 7.21 approximately. Now we need to check if either one or both the solutions are valid. And so if I plug in a positive value here and I square it, I still get a positive result. If I add a positive number to it, I still get a positive result. And I know that I can find the square root of a positive number. So far, this solution is valid. Okay, let's check the next one, and I'll show you the calculations for this one. I need to see if x squared, the square root of x squared plus 48 is a positive result. And so if I plug in negative 7.21 squared plus 48, I will get a positive result, and this is actually equal to 52 plus 48. And so what this actually gives me is the square root of 100. And again, so since this is a positive number, then I know that the second solution is also valid. So in this case, I actually have two solutions. I have positive the square root of 52, and I also have negative square root of 52. So both solutions are valid. In this case, I have no extraneous roots.